right, let's look at what we call parent graphs. Now, this right here, y equals x squared, would be a parent graph. And we're going to look at what happens. It is a basic parabola. It swings down, hits at the origin, 0, 0, swings back up. Notice it's symmetrical, perfectly down through the center there. So that's the parent graph of y equals x squared. Well, what happens if we start doing things to it? Like here, what if we add 2 to that x squared? How does this guy do? What does he do? He shifts up 2. Notice he simply went whoosh, up 2 units. Well, what if we subtract 3? Well, notice what he did. He simply whoosh, slid down 3. That's what happens. Now, in this situation, if we add 2 or subtract 3, it makes movement up and down. That's what happens, okay? That's when we add or subtract from the squaring piece, okay? From the squaring piece. That's different than this. Now look, here's our parent graph y equals x squared. Now we're subtracting from the x value and then squaring. That's what I meant when I said when we add or subtract after the squaring. See, here's the squaring, and then after it, we were doing something, okay? So here, before we square it, we're now subtracting or adding. Well, let's look what happens because it's a little different. So within here on the x, within the parentheses, when we subtract 3, notice it goes from its normal parent graph here, which we see right here, and it slides over 3. Now notice you were subtracting 3. It ends up doing the opposite of what you think. It ends up sliding to the right 3 units. Here, when you added 2, it didn't go to the right 2. It went where? To the left 2. It went back 2. So this controls movement right and left when you mess inside the parentheses before you square it. So that's what's going to happen. We're creating movement left and right. So if I had, let's say, x minus 5 squared, I know since I'm subtracting, I would think it goes left, but hey, it's going to go to the right 5. It's going to slide to the right 5. So it is the opposite. It's sort of what it's creating to get you to be 0, but we're not going to worry about that too much here. So let's see if we can determine what equations are graphed here. Now it's all going to come from, right? Trying to turn it to red. It was a challenge right here. Okay, that special vertex point. This guy, what happened? Well, he normally was right here, your y equals x squared. There's your parent graph, but it slid over to the right 2, and then it went down 3. So here's what happened. To make it movement left and right, that's messing inside with the x. We went over to positive 2. That means we subtracted 2 here. That's what made it move to the right 2. Then it went down 3. Well, that's just normal. So we just put minus 3 on the outside. What about this guy? Right here's its vertex. It started here at the origin. It went over to -1. So what happened is inside that parentheses, it went over to -1. So we actually were adding 1 to it. Don't forget the squaring because it is a parabola. And then it went down 2. So -2. That's what we have graphed there. And as we go through the homework problems, there's a video explaining each one of them. So that's basically what happens. What's inside makes movement left and right. It is always the opposite of what you would think. When you add, you're moving left. When you subtract, you're moving right. And then what happens after the squaring, that controls movement up and down. And that is what you would think. It says -2, you're going down 2. It says +5, you're going up 5. If we put a negative sign in front of our expression, it's going to basically flip it. It's going to turn it upside down no matter what happens. So our parent graph y equals x squared is here. If we put the negative, it just flips downwards. Okay. So the first thing we always look at when we're looking at graphs trying to decide what they are, if it's downwards facing, we put a negative right away. If it's upwards facing, we know it's a positive. Now, these are absolute values. Here's your parent graph of y equals the absolute value of x. It simply comes in, hits the origin, goes out. Notice it has a slope of 1, up 1 over 1, up 1 over 1. Now, it does the exact same thing. If outside, just like outside the squaring, this controls movement. If we do it outside, it controls movement up and down. vertical movement. If it's outside, just like it's outside of the squaring, or if it's outside of the absolute value. If it's inside, that's controlling movement left and right. And again, it does the opposite of what you think. This says take away 2. It doesn't move left 2. It's going to move to the right 2 and then be your typical absolute value. So if you mess inside, that's movement right and left. If it's outside of the absolute value or outside of the squaring, that's movement up and down. With absolute value, though, I am going to require that you pay attention to the slope of the line. As we put numbers out in front, it does control things even with squaring, but I'm not going to make you worry about that. I just want you to worry about it with absolute value because it's easy to do. Notice we do y equals the absolute value, a half times the absolute value of x. The slope of this line simply goes up 1 over 2, up 1 over 2. Same going left, and negative 1/2 slope. It has a slope of a half. We do want to pay attention. Just like here, y equals 3 times the absolute value of x. Notice this line gets much steeper because it ends up having a slope of 3 and 3 to the left and negative 3. So that's something we want to pay attention to. And what we finally have here, square root graphs. Square root graphs are very weird looking, but here's what they look like. Here's the parent graph, y equals the square root of x. Starts at the origin and simply whoosh, goes that way. Okay, notice it has it's like a sideways, half of a sideways parabola. Again, if we mess outside the square root, that simply has movement vertically, up and down. We said -2, so it went from where it was right here to went down 2. And if we mess on the inside, again, controls movement left and right. It said -2, so we got to do the opposite, which is add 2. And then we go like that. Now, if we had slid in a negative sign, that guy simply would have gone downwards like that. There are some quick basics. You might want to watch this again or look at the homework problems or even tune into class time to watch and see this done. Okay, I've tried to do a lot of quick examples. You need to go back and think it through.